So what do we know about polynomials, right? As I was asking you in the previous class, so as you said that it stands for nomial means number of terms, poly means one or many, right? So the on the and these are on the basis of number of terms, right? So on the basis of number of terms, on the basis of number of terms. So this is divided in what? What are the divisions? Can you tell me? What are the kinds of polynomial that we have studied?
Monomial, binomial.
Yeah, so absolutely correct. Monomial, binomial, right. And then trinomial, tetranomial, and so on. So these are all polynomial, right? Okay,
Yes.
and then we studied about the criteria of polynomial, right? So the criteria of polynomial was what? So first criteria was that it should, yeah. So okay, so it should. What is this sound? Sound?
Oh, okay.
Yes. Yeah. So criteria of polynomial was that it should not and it must. Right. So it must not contain negative power on the variables. Right. So this was one criteria that if you have, let's say, a px, which is always a join. Amira, you are also joining.
Assalamualaikum, sir.
Walaikum salam. Yes, many congratulations. So you have improved a lot, right?
Jazakallah khair, sir. Thank you so much.
Yes, good. Yeah, so keep it up and yeah, practice all the remaining ones, right? Whatever topics that you feel difficulty in. So yeah, I guess we'll practice in this class. Yeah, so we are starting from polynomials because Amar has some problems in polynomials. So we are starting from polynomials. Okay, and if you also have some doubts, then you can also ask. Yeah,
Sir, the class is on 5 o'clock, right?
5 o'clock, which is 7:30 p.m. Yes. Okay, yeah. So yes, 5 o'clock. So you joined at 4 p.m.
Yes, sir.
Yeah. So yeah, the class is supposed to be at 7:30, which is 5 p.m. Yes. Okay. Yeah, and yeah, so we'll see that if you require any doubt classes, then we can take those ones, right? But yeah, you start practicing, right? Good. Yeah, that was
Yes.
very nice to hear. Good. See you in the class. Okay.
Okay, sir. Assalam.
Welcome, Shamu. This is joining. Okay, everybody
Sir,
is joining.
because Learnivio team has sent the timings like this, so.
Oh, yeah. Okay. Hello, Aisha, is that you?
Yes, sir.
Oh, yes. Assalamu alaikum. So everybody is joining at this time, right? Because the time is 5 p.m. Okay, let me confirm, right? Because this was supposed to be Amar's doubt class. One moment, give me guys one moment. Or yeah, you guys can join after an hour, right? So at 5 p.m. Okay, is that okay with you guys? Aisha and
Yes, sir. Yes,
yes,
sir.
yes,
Yes, sir.
Aisha. Okay, so see you guys at 5 p.m. Okay,
Assalamualaikum,
Okay,
sir.
sir.
Walaikum
Nice.
salam. Allah Hafiz, guys. Bye, bye. Okay, so where were we? Yeah, so it must not contain negative power on the variable, right? So let's say if you have some terms like let's say 3x square plus 2 and x to the power minus 4 plus 3, right? So this is looking like a trinomial, but this is like this, right? So this is, and if I write it properly, right? So in fraction, this would be x to the power 4 plus 3. So this is like, right, Amal, which means that the second term has a negative power and on the variable. So this is very important. The power should be on the variable. It can have any power on the constant, but the variable should not contain the negative power. So this will not be a polynomial, right? So this is not a polynomial, right, Amar?
Yes.
Yeah. So if you see some terms like let's say x square plus 1 by x square plus 4. So is this a polynomial? Yes. Is this a polynomial, Amar?
Yes, sir, because it doesn't contain any negative variables. The negative power.
Yeah, but you see this term, right? If you write this term properly, so what would be this term? This is in the denominator you have x to the power 2. So if you take it to the numerator, so the power would be negative, right? How do you write 1 by x square? You write it like x to the power minus 2, right?
Yes, sir.
So now you tell me, is this a polynomial?
No.
Right. So whenever these terms you see, so these are not polynomials, right? So this is one criteria of polynomial. Okay. And if I ask you that, let's say you have these terms, right? So x plus 1 by x square multiplied by x cube. So is this a polynomial?
No.
No. Yeah, so you see, we have to first simplify this, right? So this is a decoy, right? And first we have to simplify things and then we can see, right? So if we simplify this thing, there are two terms and both are multiplied by this. So first we have to multiply x with x cube and then multiply 1 by x square with x cube. So this would be how much? How much is this? X into x cube. How much is this?
Mm, x x to the power 4.
X to the power 4, right? And this one, so two power are getting cancelled, so you'll get 1, right? So then this is x. Now you tell me, is this a polynomial?
Yes.
So this was looking like so this was not looking like a polynomial, right? But when we simplified this thing, we got that these doesn't contain negative powers, right? So then this is a polynomial. So this was the one criteria. The second criteria is that a polynomial does not contain negative or negative. We have talked about fractional powers, fractional powers on the wheel. Right. So if you have some terms like this, so x to the power 3 by 2 plus 2x cubed plus 5. So this is a fractional power, right? This is a fractional power. So this is not a polynomial, right? And what about this thing? If you have root x plus 4, so is this a polynomial? Yes, come on. Oh, I have not started. Yes, so is this a polynomial?
Mm, no, sir.
No, why? Yes, you are correct, absolutely correct. But why?
So because there's square in it, so
Square, yeah, this is square root, not square, right? If
it's
this
square
is
is square inside.
so, if we have this term, then this is a polynomial. I'm asking about this. So, if we write what is the square root in power, we can write this square root in power, right? So that is power half. That is how we represent the square, right?
Yes.
So now if you see what is the power, this is fractional, right? So if you have a fractional power, then this will not be a polynomial. So if you have some terms like this, 3x to the power x root x plus 4x square plus 5. So you see that again this contains fractional power. So this is not a polynomial, right? So these are the two important criterions of the polynomial, right? And after this, what did we talk about? So after this, we talked about degree of the polynomial. What was the degree of the polynomial? Degree of the polynomial was that, let's say I have given you a polynomial, right? So the degree of the polynomial was defined like the highest power on the region, right? So it is already, I have given this information already that it is a polynomial. Then what is the degree of the polynomial, right? So let's say I have this polynomial 3x squared plus 2x5 plus x plus 4. So what are the powers of variable, right? In this one, power is 2. In this one, the power is 5. In this one, the power is 1. In this one, the power is how much? What is the power in this term? Power of variable, power of x. Yeah. What is the power of x in this term?
Uh, just 1 second. Five.
5. I'm not talking about this power. This variable has power 5. In here, I can write this as 4 into 1. And we already know that we can write anything to the power 0 as 1. Right? So x to the power 0 would be how much?
One, so
Yeah. Yes.
yeah, so I thought you asked me the height, the degree.
No, no. Oh, yeah. So you thought that I'm asking you. No, no. I asked you that what is the power of x in this term? So power is 0, right? Now, if
Yes.
we compare these powers, so this one is the highest, right? So then this would be degree. So degree of the polynomial is the highest power on the base, right? So let's say if I, so degree is 5. So if I say that I have a polynomial which is x cube plus 2x square plus 5, right? So then you can directly tell me that what is the degree of this polynomial. What is the degree? Yes. What is the degree of this polynomial?
3.
3. So degree, highest power is 3, so degree is good. And similarly, if I ask you that you have a polynomial like this, so then what is the degree of this polynomial?
0.
0, right?
1.
Is it 1 or is it 0?
1. Because
1. What is the power on variable? Do we have any variable?
if any variable, then it's 1.
2 is the variable. So then you tell me what is the power of this? What is the degree of this
1.
degree? So degree of this thing is 1. But this is totally different from this thing, right? So,
Or it's then 0.
right. This thing.
Okay, that's
Yeah. So on the basis now we know that what is the degree of the polynomial. So one division that we made was on the basis of the number of terms. So there is this another division of the polynomial, and that is yeah, that is on the basis of right. So on the basis of degree, the first one is the linear polynomial. Right. The linear polynomial has a degree, and then you have this quadratic polynomial. So quadratic polynomial has a degree. Similarly, you have a cubic polynomial. Right. So then the degree is so we have to only remember these three kinds of polynomial on the basis of degree. Right. So these are the different kinds of polynomial. Okay. So after this thing, we learned about the zeros of the polynomial. Right. So what were the zeros of the polynomial? Do you remember? What were the zeros of the polynomial? Yeah. What uh, what was the zeros of the polynomial? Yes. So zeros of the polynomial, right? So the value of the variable for which for which the polynomial is zero are called zeros of the polynomial, right?
That is the opposite of degree, right?
Degree is something else. Degree is dependent upon the powers, right? We're not talking about the powers in here.
Yeah, but similar,
So
the point of the variable.
yes,
Like it's the opposite of degree, but for variables.
opposite of degree. So degree opposite of degree would be the lowest power on the field, right?
Yeah. So for variables, if you put variables, it's the lowest, the variable's lowest value.
No, no, no. So degree are different, right? So if you have a polynomial, right? If you have a polynomial and then you have these variables, right? So let's say 4x plus 5. So then degree is 2. Degree is simply the power on the variable, right? Highest power on the variable. But zeros, so let's say you have a 0 polynomial and then you equate it to 0, right? So let's say if you have a linear polynomial, right? If you have a linear polynomial and if you equate it to 0, right? So let's say if you have 3x plus 4 and this is equal to 0, right? Px is 3x plus 4. So if you equate this polynomial to be 0, then you will get some value of the variable. You will get the value of some x, right? So then this thing is 0. So if you solve this thing, you will get 3x is minus 4. So x is minus 4 by 3, right? So what is this telling us? This is telling us that if you put the value of x to be this, right? So let's say if you have a polynomial which is 3x plus 2, and if you put the value of x to 2, right? Then what would be this thing? This would be
3 into 2 into 4 plus 2, 3 into 2 into plus 4.
oh yes, Amar, light went off, right? So electricity went off, yeah, and I got it. So what was I saying? I was saying that can you hear me, Amar?
Yes.
Yeah, so I was saying that if you put the value of x to be 2 in here, right? This would be what? In place of x, you have to put 2. So this would be 6 plus 4, which is 10. So you will get the value of polynomial. Let's say if you put the value of x to be, let's say, whatever, what you want to put, minus 1. So then if you put the x to be minus 1, then this would be 3 minus 1 plus 4. So minus 3 plus 4, which is 1 again. So we are getting different values of polynomial, right? But there is this value of x. So if I put my x to be minus 4 by 3, right, then what would be the value of polynomial at this point? What would be that? So this would be 3 and minus 4 by 3 plus 4. So 3 will cancel and this is minus 4 plus 4. So what am I getting? 0. So what was the speciality about this value of variable? What was so special about this value, Amar?
So we always get 0.
Yeah, so the value of the polynomial will be 0, right? So we checked it with the different values of x. We can take 1, 2, infinity, whatever value we want to take. So for all those values, this would have different values. This polynomial will have different values. But there is one unique value of x for which the value of the polynomial is. So that those values of the variable are called the zeros of the variable. Clear? Is this
Yes.
clear? Yeah. So, what this zero, right? How do we represent this zero graphically, right? So, graphical representation. Graphical representation of zeros, right? So, if you have so in graph you have two axes, right? One is the x-axis, other is y-axis. So let's say on x-axis you take the variable. This can be x, t, m, p, whatever variable that you have, right? And on y-axis you have a polynomial which is dependent upon this x, right? And then you plot the function. So let's say you plot this function, right? So at these points, what is the value of px? At this point, what is the value of px? What is the value of px at these points?
0.
Right, because these are y-axis. So y-axis is 0 on x-axis. Value of y is 0 on x-axis. Right. So all these are 0, which means that whatever, let's say this is x1, whatever this x2, whatever this x3, whatever this x4, there are four values of x. There are four values. In the previous example, what did we see? We saw that there is one value of x for which my polynomial was 0. But in here we are seeing that there are four values. So there are four values of variable or x for which px is 0. So then what these four values would be called? these are zeros, right? So these are zeros of px, which means that there are four zeros. Clear?
Yes.
Okay. So, and these are the number of zeros, right? So the number of points, the x-axis cuts this px. Then that those number of points are called number of zeros, right? So the number of points where px cuts the x-axis gives the number of zeros. Right, so here the number of zeros would be 1, 2, 3, 4. But the number of zeros and the degree of the zeros, they are very related, right? So relation between number of zeros and degree of the polynomial, right? So what is the relation? So the relation is that the degree of the polynomial is equal to the number of zeros of the polynomial, right? So what do I mean by that? Zeros of the polynomial. So what do I mean by that? So let's say if my polynomial is 4x to the power 3 plus 2x square plus 5x plus 9. So what is the degree of this polynomial? What is the degree of this polynomial? Yes, Amar, what is the degree?
3.
3. So degree is 3, which means that there would be three number of zeros, right? And these number of zeros are also called roots. So there would be three roots for this polynomial, which means that there would be three values of x where this px is 0, right? So that is the relation between the polynomial zeros and the degree of the polynomial. Okay. And after that, we talked about, so this last topic that we did in the polynomial was the relationship, relationship between the coefficients and the zeros of quadratic polynomial. Right. So what was the quadratic polynomial? So the general form of quadratic polynomial. So this was px, which is x square plus px plus c. And if we write the quadratic equation, right? So quadratic equation when we equate it to 0, right? So that is quadratic equation. So we have this polynomial, and if we equate it to 0, then that becomes quadratic equation. quadratic equation is ax square plus bx plus equals to 0. So how many zeros would be there? How many roots would be there for this equation? How many zeros would be there?
2.
2, right? Because degree is 2, so there would be 2 zeros, right? So there would be 2 zeros, and we call them, let's say, alpha and beta, right? So one value of variable is alpha. This alpha could be 1 by 2, 3, 4, 5, minus 3 by 5, something, anything this alpha could be. And then the other value of variable is beta. So these are the two values of the variable or the zeros. So these are 2 zeros. And what are the coefficients? So coefficients are A, B, and C. So all these coefficient and all these zero, they are interrelated, right? So one thing is sum of these. So sum of the zeros, sum of the zeros, which is what? So we are summing the zeros. Zeros are alpha and beta. So sum of the zeros is alpha plus beta. This is the sum, and this is equal to minus b by a. And the second property is the product of the zeros. So product means that we are taking the product of alpha and beta. So that would be alpha into beta, right? Which is alpha and beta. So this is C by A. So these are the two important relations between the zeros and the coefficients. Sum is minus B by A, and product is C by A, right? Where we know that what is A? A is the coefficient of x square, B is coefficient of x, C is constant term. So these are the things in important part, right? These are the things that we have done in poly. Here is this clear?
Yes.
Okay, so what was the doubt in the polynomial? Can you tell?
So like when doing questions like that.
Oh yeah, so let us do some questions, right? And there is this, yeah, so, okay, so if you have a quadratic polynomial, so shape of quadratic polynomial would be like this. So this would be the shape of the quadratic polynomial. One would be like u. So this u can be of this type, this u can be of this type. Anything would be there. Or this u can be so this type. Okay, so this can be this type also. These are the structures of, or maybe like this also. So all these are quadratic polynomials. Okay, these are the quadratic polynomial. And how does we decide, or how do we recognize that what shape could be this? So if that is dependent upon the power of A or the sign of A. So if your A is positive, right? So this is given also in the book. Yeah, so in NCRT book, this is so this was asked in Hashid exam, right? And yeah, so this is written in the card. So if you have A which is positive, right? If you have a A which is positive, so this would be U, right? U kind of shape. If your A is negative, then this would be like this, right? So if you have without doing any calculation, right? Without doing any calculation, if the polynomial is given like this, so you can identify that the polynomial would be like 3x square plus 4x plus something, right? Because this a is negative, or this should be positive, right? So this should be positive. And if you are given a polynomial like minus 4x square plus 3 5x plus 2, so you can say that the shape of the polynomial would be this. Okay, is this thing clear? Yes, these are all not that much important, but okay. So now let us do some question, and then this would be yeah. So let us start from. Okay, so this one is the first question, right? So first we have to find the roots, and then we have to decide whether what is the relationship between zeros and coefficients, whether they are correct or not. So we have to verify the relationship between the zeros and the coefficient. So you have this quadratic equation and you already know how to solve, right? How many methods do you know, Amar, to solve a quadratic equation?
We have to prove that this one the equation equals to zero. So we have to find a suitable substitute for
Yeah,
x to 0.
so we have to find the value of x in here, right? We have to find the value of x, and you already know what are the methods to find the value of quadratic equation. What are the methods that you have learned? Basically, we have learned two methods. Can you name them?
Alpha plus beta sum of zeros and this
Yes.
the sum of the zeros and the product of the zeros.
So those are relation between the zeros, right? Sum of the zero is we need to find out the zeros first. So we did or we learned two methods. One was middle term splitting, right? Middle term splitting method we learned, and the other one that you so not in this chapter but in the later chapter you learned about this quadratic formula. So these are the two methods that we have learned, right? Do you remember these two?
Quadratic formula x square by
Yeah, so quadratic formula was that alpha and beta would be minus b plus minus root d by 2a, where d was b square minus 4ac. But this we will not use, right? In here, this we will use in quadratic equation. But middle term splitting, this thing we have done numerous times. So do you remember this? Yes.
we split the middle term like to two different things.
Yeah, yeah. So we split the middle terms in two terms. Yeah, that is absolutely correct. And there was a specific criteria to do that, right? So please solve this equation by middle term splitting and tell me what are the values of x that you are getting. And if you don't remember the middle term splitting method, then tell me. Do you remember that?
No, sir. Like on later, I can't remember that much.
Oh, yeah. So you have got it. Okay. So in the middle term splitting, what did we do? So we have to split this term. To do that, first we have to find out what is the product of A and C. So what are A, B, C? A is what in this equation? A is what?
X square.
A is
X square.
A coefficient of A,
Ah,
right?
1.
So coefficient of x square is 1, right? B is how much?
2.
B is 2, or what is the sign? Please,
Can you repeat again?
yeah, what is the sign? B, what is
Minus.
the minus? So this is minus 2. And C,
Minus 8.
minus 8, right? So, okay, so these are the values, right? Now, now we have to find the multiple of A and C, right? So we will, for now, we will not consider this minus part. But A into C is how much? That is 1 into 8. So that is 8, right?
Yes.
And second thing is that we have to factorize A into C, right? Which is we have to factorize 8. So factors of 8 would be how much? That would be,
2, 4.
so that would be 2 into 2 into 2, right? These are the factors of. Now we have to find two factors of 8 such that their multiplication would give you minus 8, right? Their multiplication would give you minus 8, and their addition or subtraction would give you minus 2. So what would be those factors?
Minus 2.
Minus 2 and what?
Minus 2 in minus 2 into minus 2 into minus 2 into minus 2.
So we have to find out two factors, right? Not three.
Yes. Minus 4.
So minus 2 and minus 4. Yeah, these are what you are telling. So if you
Yes.
multiply these two, what will
Mm,
you get?
yeah, it's positive rate. So minus 2 by 4.
By 4 we cannot, we are multiplying, right? So
Yeah, minus 2 and minus 4. I mean minus 2 and into minus 2 and 4.
minus 2 and 4, yeah. So, okay. So you are saying, is join? It is okay.
Okay.
Yeah.
Yeah.
So
So
mine, why my voice is echoing? So if you multiply minus 2 and 4, you will get minus 8. So this is fulfilled, right? But if you add minus 2 plus 4, how much you will you get? What you will get? Yes, what you will get? Minus 2 plus 4 would be how?
it will be plus 2. So
Plus 2, right? So then
2
this is not
into 4.
minus 2.
2
So
into
yeah,
minus.
2 into minus 4. Okay, so let us change that. So 2 into minus 4. Yeah, so 2 into minus 4. So what is the product? Product is minus 8, which is correct. And then 2 minus 4. How much is this? That is the minus 2. So this is there, right? So factors should give you A into C and minus C, right? Yeah, so this one is correct. So 2 and minus. So then we will write this equation as plus 2x minus 4x minus 8 equals to 0, right? And you can see that if you add 2x minus 4x, then you will get back this thing, right? So then we take common. and x we take common, so this would be how much? If you take x common from here, what would be the remaining answer?
X into 2.
X into 2. So 1 would be x, this is plus, right? So plus, and you have
Plus.
taken, so this would be there. Now you have to take something common in such a way that you get x plus 2. So what you should take from this minus 4x, that you get x as a common. You have minus 4x. You take minus 4 power so that you get x as a common, right?
Yes.
So you take minus 4 common, so this would be x, and this is minus 8, you have taken minus 4, so this would be plus 2, right? So again you have these two tops, but this x plus 2 is common, so you again take common, so this would become x plus 2 and remaining is x from here, and from here minus 4. So these are the two terms. One would be x plus 2 equals to 0, other is x minus 4 equals to 0. This is x equals to minus 2. This is one root, x equals to 4. So you have got two roots. Alpha is minus 2, beta is 4. Right? So you have got these two roots. Right, Amar?
Yes.
Okay, so we'll stop it here at here because the next people will be coming, right? So yeah, and you please solve all these questions, right? And you practice this middle term splitting because this is very crucial, right? So you practice this
Yes.
thing, and then when we meet on Sunday, right? So then we will talk about all these things.
Okay.
Yeah, so come back in 5 minutes, right? You take a 5 minute break and then come.
Okay.